So I'm going to officially start our meetup now. So thank you everyone for coming to Accessibility Virtual Reality, where we've been on a small hiatus. So we're very excited to have a new event and to have such a big interest from people all over the world for the presentation today. We always emphasize that we are committed to making sure that this space and this experience is accessible and available to everyone. So please share your feedback either via chat, via the Meetup page, via our Twitter. We're very responsive to any feedback on how we can improve this experience and continue learning how to ensure that virtual reality social experiences are accessible. We have been very happy working with the Mozilla Hubs team. They have been very receptive and been able to add features to make the experience better to use already from feedback that people such as yourselves have given us at these meetings. And I do want to emphasize we will be having a presentation in the future with the Mozilla Hubs team, where they'll talk about some more of the work that they're doing on making this space accessible. My name is Thomas Logan, and I'm the owner of Equal Entry, and I'm the organizer of this event. And I am committed to having virtual reality be accessible sooner than later. So one of the goals of all the presenters and presentations that we host here is to spark discussion and help learn from each other about what can we do to make these environments accessible now. Part of what we do to make the environments accessible now is we do stream our events to YouTube for every event. So we have Jolie McPhee from the Internet Society of New York today providing the live stream to YouTube. If you're unable to get into the event because we've reached capacity, you can always join the YouTube live stream, and we monitor the questions on the stream, and we'll ask them of the presenter. And we also want to thank Stanley Sakai, the captioner for today's event. And so every time that we host our events, we have a human captioner providing the text description of what everyone is speaking, and we have that displayed underneath the slides in today's presentation. If for any reason you would like to have those captions be magnified or focused on, similar to how you hovered over an avatar to boost the audio, you can focus your mouse pointer over the captions, hold the space bar down, and then click the magnifying glass, and that will give you a view of the captions that will be in your viewport. And with all that being said, I would like to introduce our speaker tonight. We have Martez Mott. He's a senior researcher in the Ability Group at Microsoft Research, and his research is focused on designing, implementing, and evaluating intelligent interaction techniques that improve the accessibility of computing devices for people with diverse motor and sensory abilities. So very thrilled to have Martez here tonight. Take it away, Martez.
Yes, thank you so much, Thomas. I really appreciate you having me. I'm really excited to be here with you all and to be able to chat with you about some of the research that I've been doing over the past year or so, and to really hear your feedback and just to kind of have a great conversation. So thank you again for having me. I'm really excited. So I want to kind of preface this and maybe apologize up front just by saying that my background is in academia, so I'm typically, think of myself as an academic. So I hope my presentation today isn't too, doesn't drawn on too long, but I wanted to be able to provide an overview of some of the, not only the research that I've been doing in the last year or so, but to kind of give a little bit more insight into my research approach and how I think about the research in this space. So, another note before I kind of get started here. I tend to like to have pretty interactive presentations and events. So by all means, through whatever mechanism is most appropriate or best, feel free to stop me or interrupt me during the presentation if there's something that piques your interest, or if I kind of didn't explain something in enough detail, or I just kind of went past something, feel free to stop me. I love to kind of have these interactive conversations. So, okay. All right. So, just to get started here, I want to provide just a little bit of background on me really fast here. So, I did my bachelor's and master's in computer science from Bowling Green State University. Bowling Green is a smaller state school in Bowling Green, Ohio. And then after leaving Bowling Green, I went and started my PhD at the University of Washington in the information school there. And I graduated with my PhD there in 2018. This is like a really nice picture of the University of Washington campus. And currently, I'm a senior researcher in the Ability Group at Microsoft Research. The image on the screen now is a picture of Building 99, where Microsoft Research is in Redmond, Washington. And essentially, our group investigates various types of um, accessibility concerns and tries to come up with novel solutions to help us kind of overcome them. And we do that through partnering with various people and trying to really strive towards coming up with some useful inventions that can improve a lot of the accessibility concerns that a lot of people have. Okay, so really quick, I just kind of want to give an overview of what I'll be talking about today. So this is I give this presentation, typically to kind of like more general type of departments, or like at a university or something. So I know people here already have an interest in accessibility. So I think this first part around accessible computing, I essentially just want to talk about kind of like in my research, how do I think about accessible computing, and how does my conception of accessible computing then lead to how I conduct research in the accessible computing space. So that's going to talk about for the first two things really briefly, how I think about accessible computing, how that impacts my research approach. And then the final parts I'm going to talk about are going to be what work are we doing to move towards more accessible VR, particularly for people with limited mobility. And then I'm going to end by talking about some future opportunities. So things that we're thinking about currently, but we haven't had the opportunity yet to maybe explore further.
Hi, Martez. Just a pause for one moment.
Yeah.
I just noticed the captions got hidden for the presentation, so just want to check really quick. Is anyone else able to see the captions, or have they just disappeared? If you could type in the chat. They're gone. Okay. Jolie, can we bring the caption display back in? All right, sorry. Sorry, Martez. We'll just take a quick pause to get the captions displaying.
Yeah, no problem at all.
Yeah. Oh, I see them. Okay. Let me fly over and grab them. Okay, we're captions actually disappeared behind this wall here. Take a second. Julie, can you try to reshare them again? I'm sorry, I can't navigate behind that wall. Okay.
You should blow them up first before you put them into place, or does it pin and it blows up?
Now it pins. It pins in. It pins in there. If you can try and grab it. For some reason, my avatar. I'm gonna have to take a note of this for our world designer, but I can't walk right up to the slides to drag them in. I should be able to do it now, actually. Yeah, they do pin into the space.
Hello?
I don't see them now.
Can you bring them in one more time?
Okay.
Apologies, everyone. This is live. This is using Hubs to pin an object. There is a new feature in Hubs where you bring your object. I'm using my mouse. And I'm rotating my view, and I'm dragging these down into the space. So there they are, and they're back. And we'll get back to Martez now. Thank you.
Hello.
Okay, great. Thanks, Thomas. Okay. Yes, so accessible computing. Okay. Sorry, I forgot where I was for a second. Okay. First I want to start off by providing a definition. So this is kind of the way I think about accessible computing and some of the work I do. So I tend to think of it in these kind of two ways. So the first is designing computing devices and services to be usable by all people. And then the second is using computing to make the world more accessible to people with disabilities. So I really think about accessible computing as performing these kind of two different roles. And in doing so, we've come up with a lot of different design paradigms to help us accomplish that. So probably the most common, the most well-known is universal design. So I have a definition here that I want to say. So it says universal design is the design of products and environments that can be used and experienced by people of all ages and abilities to the greatest extent possible without adaptation. So universal design is really popular. It actually comes out of architecture and like built environments, with the idea being you want to create built environments that can be accessible to all people, but it was kind of co-opted by the accessibility computing community as a way to also think about how can you conceptualize accessible design for other different types of products. So this is really useful, right? Because it could give you really great things, like, you know, this curb cut example is kind of like the canonical example of this, which is you provide a benefit to one group of users, for example, perhaps people who might use a wheelchair, but then you get these kind of second order benefits for people who might be pushing like a grocery cart or, you know, riding a bicycle, something like that. Same thing with closed captions. It could be great for providing audio, if providing textual descriptions of audio information, which can be great for accessibility, but can also be really good if you're trying to, I don't know, watch a game at a really loud restaurant or something like that. So I want to return back to this universal design definition really quick, because I think there's something really interesting here. So just to recap, the definition says the design of products and environments that can be used and experienced by people of all ages and abilities to the greatest extent possible without adaptation. So this notion of abilities here is interesting because it kind of begs the question, well, what is ability? Like, what do you mean by ability if you want to be able to accommodate the greatest extent possible of what these things are? So we can have a couple of different, once again, these like shorthand definitions that can help us out with that. So one way to think about ability is you could think about it as just being, it's just having the possession of the means or skills to do something. So if that's kind of your notion of ability, I think that gives you a really broad understanding, because I think we can all relate to this. Like, we all possess the means of skills to do some things, but we don't possess the means of skills to do other things. So it provides this notion of like ability lying on the spectrum. So then I also ask the question kind of, well, what is disability? So if you go through the World Health Organization's updated definition of what is disability, you know, we move towards the more social model of thinking about disability, is that disability isn't something that's inherent within a person, is something that's is contextual, and is something that's actually influenced by the environment, right? So it's not just what a person can do, it is what does the environment allow people to do given what constraints and etc. So this is all useful, and it brings us to kind of what I think of as my overarching kind of design philosophy, and it's something called ability-based design. So this, similar to universal design, is just another design approach. But in this approach, what we try to do is we try to think about the human abilities required to operate an interactive system, and we try to question them, and we try to create systems that can adapt or be adapted to alternative abilities. And the useful framing here is that it provides us something called this positive affirmation of ability. So it says that everyone has abilities, some people more than others, and this is true for anything. And we need to design for people with abilities of all types. So this is just a really quick background of just how I think about accessible computing and how these different types of design frameworks within accessibility can be really useful for orienting yourself when trying to accomplish a research project or something else in this space. So now that I started off with kind of how I think about accessible computing, I wanted to talk a little bit more about my specific research approach. So typically what I do in my research is I try to understand what we call ability assumptions. So I'm going to make a statement here, which is that all human operated technologies contain embedded ability assumptions, whether explicitly or implicitly. So these ability assumptions dictate how we use everyday devices. It doesn't have to be computing devices. It could be anything that's ever been built by a person, right? It could be a hammer. If a person designs a hammer, that person's designing that hammer assuming people have certain abilities to be able to use it. And we do the same thing when we design computing systems. So what we try to do, or at least what I try to do in my research, is I try to question those. I try to interrogate those and say like, okay, you know, in our design, what are we assuming? What are we taking for granted? What are we thinking that people can do, and what are we kind of, how are we limiting ourselves and what we're assuming people can do, and things like that. Just really quick, this isn't VR related, but just to give an example. So for example, for my dissertation work, I looked at kind of like the accessibility of touchscreen devices, with the idea being that, well, how can we think about how to make touchscreens more accessible to people who might have limited mobilities? So these might people who might have limited dexterity in their hands or fingers. These might be people with poor coordination or limited movement, rapid fatigue, poor strength. All of these different things can impact how you might interact with a touchscreen device, for example. And if it's difficult, for example, for somebody to do something like tap with a single finger or gesture with a single finger, then we really need to reconsider how we're designing these type of systems. So my dissertation work was investigating these different types of questions and trying to come up with solutions that would help that in some different ways. So in general, my research approach kind of follows this kind of three-step process of really trying to identify and question these ability assumptions. And then in my work, primarily what I do is I create what's called interaction techniques that take advantage of what people can do. So these interaction techniques dictate how people interact with their computing systems. And if you have interaction methods or input methods that are inaccessible to people, you want to be able to devise alternatives that are more accessible. And then finally, we kind of do this evaluation approach, right, where we actually build these things and then we actually have target users give us feedback, not only just at the end when we actually do the evaluation, we actually do kind of at a more integrated design process where we actually work with people throughout the entire designing and building, multiple rounds of iteration, et cetera. But at the end, we also want to have a prototype that we can actually test and say like, hey, how well did we achieve our goals, right, for these different type of scenarios? So that's kind of, that's a little bit about like my research approach and how I think about that. I just kind of wanted to be able to get that out of the way because I think it might give some useful framing for some of the research that I'm going to talk about now. So in this next section, I'm going to talk about the research I've been doing since I joined Microsoft Research about 2 years ago now, and this work has been really ongoing for about the last year and a half. So me, myself, I'm new to the virtual reality space. I hadn't been working in this area prior to joining Microsoft Research. I didn't do my dissertation work in this area. So it's been a really interesting and fascinating experience for me to kind of get embedded in this community and to try to understand the accessibility challenges that exist and to try to hopefully propose some useful solutions and ideas that can be useful to the community. So that's kind of what I want to talk about today. So this is very preliminary work, is very kind of like current stage work. I mean, like all of us, the coronavirus pandemic has impacted, you know, our lives in very significant ways. And it's very hard to do this type of research of actually, you know, being able to bring people into a lab, have people try different VR experiences and things like that when you can't be near people. So some of the things I'm going to talk about today are going to be kind of like studies that are currently in process or things that we've thought about more broadly, but we haven't been able to fully explore yet, just because we haven't actually been able to work with participants as closely as we would like, given the pandemic. So just kind of keep that in mind. And, you know, if you have questions and things, that's kind of the state that we're in right now. Okay, so since this is an accessibility VR meetup, I don't have to explain to people here that virtual reality has an accessibility problem. So what I have on the screen here is a clip, kind of like a screenshot of a headline from the Scientific American that says VR has been touted as an empathy machine that lets users see what it's like to have a disability, but people with disabilities often can't use it. So in general, it's been kind of documented for a while now, all of these various different types of accessibility concerns that exist with virtual and augmented reality type of systems. When I joined Microsoft Research, my colleagues and I, we ourselves wrote a paper that we submitted to a conference. It's kind of like this short position paper titled Accessible by Design, an Opportunity for Virtual Reality. And the idea here was that we wanted to identify some areas that we thought the academic community may be missing out on in terms of thinking about how virtual reality should be designed. Because, you know, virtual reality research has been conducted, you know, for the past 40 years or whatever the case may be. So people have been working on these problems for a really long time, but accessibility, unfortunately, is something that often gets considered primarily when commercial or when systems are going to kind of reach that commercial viability point. So we kind of missed out on opportunities in the 80s and the 90s, for example, to do a lot of groundbreaking research on accessibility in VR. So we're kind of catching up and trying to do that now, unfortunately. So we highlighted 5 key areas of focus. So these are things that we thought the academic community could really focus on and actually make a real big push, right? We were trying to do this as kind of like a call to action to the academic community who we primarily interface with. So these 5 key areas of focus. So the first is content accessibility. Second is interaction accessibility, device accessibility, inclusive representations, and application diversity. So I'm not going to talk about all 5 of these key areas right now. I'm going to talk about a couple and then kind of hit the rest at the end, kind of like as a closing kind of thought. So first I want to talk about device accessibility. So there's this thought, you know, that I mentioned earlier about these ability assumptions. So when commercial VR devices come out, they too have these embedded assumptions about how people can use them. So for example, if you have a VR system that kind of comes with the standard HMD and maybe it comes with 2 motion controllers, things like that. And if that's the primary way that you expect somebody to interface with the technology, well, what problems could that pose then if, for example, motion controllers are inaccessible to somebody? Right. So we need to rethink about kind of like the devices themselves and how they can be more accessible. So one of the ways that we think about this is that this could facilitate the need for more customizable hardware, more customizable, you know, virtual reality, augmented reality, spatial computing more broadly related hardware that's not just focused on 2D input scenarios for desktop and mobile computing. And then the other thing is, how can we integrate virtual reality technologies with accessible technology? So how can it be that people can use the accessible technologies that they use every day currently and just integrate those with VR? Like, there shouldn't have to be an either or. People should be able to have the option to choose. So some of the prior research that's been done at Microsoft Research in this space, not for people with limited mobility, but for blind and low vision people, has been this notion of, or this project they call it the cane troller. And it's a really clever idea, with the idea being that, you know, you can create this kind of custom haptic device that mimics what would be kind of like a standard white cane that would give people that opportunity to use their kind of standard white cane practices in a VR environment and to get kind of like actual haptic and tactile feedback, you know, about what's happening in the virtual world. So for example, the idea could be that, you know, you encounter a trash can in the virtual world and your cane troller actually stops and makes a sound similar to that as if it had hit the trash can in real life. So that's one example, right, of thinking about different types of devices that can be more specifically tuned for people. So once again, this is work that had been done before I started. So when I came in, I was really trying to think about well, how can we think about device accessibility for people with limited mobility? So I really started off with these questions. Well, what accessibility barriers do people encounter now when trying to use current VR hardware? So like, what are the current pain points? And then for people who have used VR in the past, kind of like, what are their strategies been? How did they overcome these kind of accessibility barriers? What can we leverage from their knowledge and practices to expand that and make it more general for everyone else? To do this, we conducted a study where we kind of recruited 16 participants with limited mobility, so people with various types of either injuries or medical conditions. At this time, we were still able to do in-person studies, so this was kind of last summer, no, not last summer, but summer 2019. So we did two kind of groups, one in person and one remote, interviews with people. And of that, we had 4 people with some prior VR experience. And what we did is we just had them try out a couple different VR applications. So it wasn't like a specific task. It was kind of like, hey, just like, play around with these things and let us kind of know what your experience was like. So we had people try out All Space VR, kind of like Oculus First Contact application, and also kind of like had people exploring around in Google Earth. And from our study, what we found, or what we were able to steal down from those interviews, is what we came up with. This is like 7 VR accessibility barriers, primarily related to the physical devices themselves. So this may not speak to any one particular type of interaction that one particular game or application might provide. It's really just thinking about like, okay.
Starts and the rain ends.
Okay. Yeah, so looking at the physical kind of accessibilities devices and trying to and figure out kind of like, hey, at this level, if we can't have the devices themselves be accessible, then the applications that they run on also will be accessible. So we kind of have to think about the device accessibility first. So a couple of different things here. So we had setting up a VR system, putting on and taking off HMDs, adjusting the HMD head strap, which you might think is like 2 and 3 seem to kind of be the same, but they're slightly different, and I'll talk about that in a second. Cord management, so if you had any type of tethered HMDs, that could be a problem. So manipulating kind of dual motion controllers, inaccessible buttons, and maintaining view of controllers. So I don't want to go through every single one of these, but I did kind of just want to talk about a few of them. So this notion about adjusting the HMD head strap or taking on and putting on the HMD in general was a big problem for people, primarily for people who may have limited range of motion. So for example, some people may not be able to lift their arms above their chest or above their head. So the idea that, hey, I have to kind of put this wearable device on and off myself. And there's also this problem that like these things aren't really built in a way to help or to facilitate someone helping you do this, right? So it's not really a 2-person, it wasn't really designed kind of thinking that like, hey, this might be like a 2-person activity. So there could be a lot of problems associated with that. And I think there's going to be a big barrier of entry to VR if we can't come up with more accessible ways for people to be able to put on and remove HMDs and other different types of wearable computing devices. But this thing about the HMD head strap I thought was really interesting just because it interacts with a lot of different things. So this one participant wrote, one thing I noticed is that the back strap thing on the back is thick. So meaning kind of the adjustment knob that you use to tighten your HMD onto your head. So they say the backstrap thing is thick, so it does touch my headrest. So that's another factor that makes it a little bit more difficult to move my head. So what they're kind of really speaking to is this idea that, for example, if you use a power wheelchair and you have a headrest and you have this kind of clunky headset on as well, and you have this big adjustment knob or other different types of things that are kind of like located on your HMD, is interacting with other assistive technology that you might also be using, right? So we need to think about ways that how would people use these devices in conjunction with other different types of hardware and devices that they might currently use. So that was one. So the other thing is just manipulating dual motion controllers, which is probably like a really common problem that people here may already know of or think about. But I think kind of having like quotes from people gives a little bit of texture to what the exact problems might be. So another participant 14 said, I can only use one hand for the controller. So I use my right hand to control one of the sticks. And I think having a one hand barrier is quite common for people who have strokes. So if you have done a lot of these interactive VR experiences, the idea can be, hey, we want you to really move in a way that simulates how you would perform an action in the real world. So for example, it might be something like, hey, we want you to climb this ladder in this VR game. And to do so, you kind of have to do hand motions that mimic how you would climb a ladder in the real world using two hands. But the idea would be, what do people do when they encounter these kind of situations in a VR environment? And perhaps they can use one controller quite fine and perfectly well. But how, would this work if these VR experiences are expecting people to be able to use two hands all the time? Or maybe not even all the time, but some of the times to be able to perform certain interactions or engage in certain experiences. Okay, and then this is probably like the most common. I think it's also inaccessible buttons. It's also probably one of the most common from more traditional kind of console and PC gaming. So the idea being that on these VR controllers, you have a lot of these buttons and triggers, and it can be really difficult to be able to manipulate these, independently or simultaneously. So we had one participant 6 wrote or said, yeah, I think walking was pushing it down. So this was an experience where they're trying to like walk in one of the VR environments. So you have to push down on the joystick to kind of have your avatar walk. So they said, yeah, I had to use two hands to leave. So I had to leave the other controller to do it. So as soon as I heard that you have to push it down, I was like, yeah, nope, that's not going to happen. So one of the other things that we found in terms of talking to people, we're trying to understand like, okay, well, what are some things that people could potentially use that could be really useful to them? But maybe we don't have really great methods or design strategies yet to think about that. So the first was kind of just, well, people said like, it would be great if I could just use whatever input controls I currently use to be able to control whatever VR interface I have. Like, why should I have to go out and procure another device? I have a level of proficiency with the devices I already use. Why can't I use these things in a VR environment? And then the other people said like, like, hey, can I use gaze or voice? And I think these things could be really beneficial. I mean, I think giving people choice is always better. I think if we wanted to expand choice, I think you would always want to err on that side. But there's also a lot of these tricky things, right? So for example, some people have like dialectic speech, which makes it really difficult for speech recognition systems, for example, to understand their voice commands. So that could be problematic. And then gaze input can be really great, but gaze input also can be really problematic depending on a lot of different, external factors. For example, just like changing the lighting that you're in could make gaze input just that much more accurate or inaccurate. So there's a lot of challenges here trying to understand how to fit all these things together. But we think it's a useful area to think about is how can we leverage all of these things to do something useful. So one thing that we thought about after doing this study was, well, how can we leverage, what devices and things like that that people already use? So a colleague of mine, Dr. Patrick Carrington, who's a professor at Carnegie Mellon University in Pittsburgh, Pennsylvania, he conceptualized this term, what he calls charitable computing. So charitable computing is technology that takes advantage of the space on or around a wheelchair, much as wearable computing leverages on-body and worn mobile technology. So from talking with Patrick, the idea was saying that like, hey, if we can have something in which people can leverage one, input devices that they either already use or have some familiarity with, and perhaps we can place these things in a location that's much more accessible to people and, require less energy and effort to be able to reach, that could be a really powerful combination, a really useful way of thinking about how to improve the accessibility in that space. So one of the things we were really thinking about was just like this kind of general question of like, well, how do we leverage more traditional 2D input devices to control more complex spatial interactions? So that was kind of our question. If we can understand how, joysticks and, buttons and sliders and rotary dials, these kind of traditional 2D input methods, how can we leverage those to do more complex spatial tasks? So you might be asking yourself like, okay, well, what's an example of a complex spatial task that could be really good for this? And one that we identified was virtual hand manipulation. So this might be a slide in which you might actually want to zoom in if you're in the room to be able to see a little bit more clearly. But essentially what I have here is a list of different types of hand manipulations that you can do currently, kind of like with just like an Oculus kind of touch controller kind of setup, right? So you could do things like perform a thumbs up or extend the single finger. And you can also interact with objects, right? So you can grasp things and throw them and release them, rotate them in various fashions, right? So this is something in which with current kind of VR technology, right? If you're using, Oculus or similar type of touch or motion controllers, you could perform these type of interactions. But what if you were just using a joystick or a touchpad, or maybe you're using some other combination of devices, but how would you perform these interactions, right? Given a more limited or more restricted input device. So that was kind of the question we had, like how, if we wanted to be able to do these things, how would people want to do them? So we conducted something called a user elicitation study. So effectively in a user elicitation study, what you do is you provide something called reference to people, and they provide something back called symbols. So in this case, if I can go back one slide. So all of these different hand manipulations here would be reference. And what we would do is say we would provide a reference to someone and say like, hey, how would you do this kind of roll right rotation given some type of input device? So there was a total of 16 different hand manipulations, and we used the touchpad as kind of our preferred input device for this investigation. There's a couple of reasons for that. So one is that in some of Patrick's prior work, he found that you can actually use the armrest on like a wheelchair or a power wheelchair can actually be a really good vehicle for a touch capacitive surface. So you can kind of instrument that to actually create like a 2D touch surface that could be really beneficial to people. And then another thing is that people also may mount touchpads on or near wheelchairs for various situations. So we thought the touchpad could be a useful implement to understand, hey, just, if I gave you this input device, what would you think, how would you perform these different types of interactions? And for our analysis, I'm not going to stay on this long. For our analysis, we use something what's called the taxonomy of surface gestures. So the idea is being that if people perform gestures, you could use this taxonomy as a way to analyze them and to get a better understanding of how people are performing different types of gestures. And it gives you a way to be able to categorize and compare different strategies and things like that. So it's useful kind of a taxonomy for performing these types of analysis. So some things I want to share, for example, is that, so some of our initial findings, so this is still, like I mentioned, ongoing research. So what we noticed, for example, is that when we had people do what we call these discrete hand gestures, so discrete hand gesture would be something like performing a thumbs up, extending an index finger, making closed fists, things like that. People had difficulty trying to generate an action that they would perform on the touchpad that would perform these actions. So what we would get as responses most of the times are what's called abstract gestures. So abstract gestures are things in which the gesture that you suggested doesn't really have any relevance, or maybe not relevance is the correct word, isn't really similar in kind to the gesture actually being performed. So for example, if I ask somebody to make a thumbs up and they said, okay, to make a thumbs up, I would tap on the touchpad 3 times. That's kind of an abstract gesture. That's an abstract gesture. There's nothing inherently related to tapping a touchpad 3 times to making a thumbs up or extending an index finger or something. But if we compare that to the more action style gestures that we had, so things like grasping a cube and releasing it, we found that 57% of those were metaphorical gestures. So what do I mean by metaphorical gesture? So let's take this example of what we call a dichotomous referent. So a dichotomous referent here would be like, grasping something or releasing it, you're doing the same thing, but not the same thing. You're kind of doing the opposite of some order or some action. So what we notice is that people will actually use metaphors quite well to describe what gesture they would perform to perform this action. So for example, when we asked participant 16 how they would grasp this cube using just a touchpad, they said, well, I would just kind of squeeze my fingers on the touchpad and that's how I would grab it, right? So it's kind of, the gesture is similar in form to what the action is actually doing, right? You're actually squeezing your fingers together. It's kind of mimicking what you would do if you were grasping an object. It is similarly to release an object, they said they would extend their fingers to release. So we've been finding that people have actually been able to come up with strategies to actually do some of these complex interactions with input devices that they weren't originally designed for. And our hope with this research is that we would be able to kind of distill some of these recommendations down and give designers a sense, or at least a way to understand how they might, from the start be able to support these different types of interactions, considering that future interactions with VR may occur on different types of devices that aren't going to be these kind of, motion tracked touch controllers that exist currently. So really brief on the takeaways from this kind of one project, or at least this device accessibility part that I talk about really quick here. So one of the things that we talk about in one of the research papers that I talked about is this notion of designing for interdependence. So most people probably know independence, being able to think about how people can, be self-sufficient and do things on their own. But the scholar, Cindy Bennett, she came up with this notion and introduced it in the HCI context. Well, not introduced independence, but she didn't come up with it, but introduced it into this HCI context of saying that, well, people with disabilities actually had these very complex, relationships with, family members, caregivers, friends, and all these different ways. And we can leverage that to actually make the hardware more accessible. So if you're thinking about how to make VR hardware more accessible, don't just consider a situation, for example, that a person's doing something independently. You might want to consider that people are working interdependently to be able to, for example, put on a VR headset or to be able to set up their VR environment, right? So if you use like an Oculus system and you want to set up your Guardian system, how could you have that system be done in a way that maybe two people can do that in a much more collaborative type of way that makes it more accessible? So designing for customization is kind of like, really brief thing about just thinking about like, hey, we need to be able to provide more options. The more customizable our input controls and interactions methods can be, the better. This notion of designing for accessibility is really this notion of really thinking about like ability, right? So, you want to be able to think about different abilities when designing these types of systems. And diversity, we really mean here is that, in our interviews, we found that, people said they wanted to interact in VR in a lot of different ways. And from some of the conversations I've had with people who create VR systems, they often come into it with a certain way that they expect people to be able to use it, right? They have a certain experience that they want someone to have. And then if you tell them that like, hey, I'm going to alter that experience, they think it's kind of breaking from that original vision. And what we have from our participants is like, hey, I don't care that I'm not using or engaging in this experience the way the developer, the creator intended. I just want to be able to engage so that I can have, social interactions with my friends, or be able to just, be a part of the conversation when these things become more mainstream. So I think those are some kind of high level takeaways from this device accessibility part that I mentioned. And so the last thing not the last thing, but kind of the next thing I want to talk about is this interaction accessibility. So I kind of mentioned the devices, that's kind of like the hardware level. How do you interact with things? So then the interaction part is like, okay, you have an input device or some type of device. How you interact with the system is this language that you have to construct, right? So we have to think about how we can kind of extend the use of, or how we can think about why VR extends the use of these physical inputs in these ways, and how we can overcome that through these different types of interaction techniques that we can create. So one of the things that has been done previously, once again, for looking at people, or looking at solutions for people who are blind or have low vision, is this notion of seeing VR, in which I'm sure many people might be familiar with this because I think it's made a lot of rounds and it's been really good in the community so far. But it's essentially a set of tools that people can add in, and it essentially gives you these kind of post hoc accessibility improvements. So you can do things like add a magnifying lens or different types of edge enhancements and magnifications, etc., in order to make a VR environment more accessible. So when I talk about like interaction accessibility, this is the kind of things I mean, kind of like more at the software level rather than what are we doing to make the physical devices themselves more accessible. So I wanted to go to another quote that came from this interview study that I mentioned. And this really kind of got us thinking about this notion of accessible bimanual input. So one of our participants 10, wrote, I'm not sure that that will be possible for me to do them simultaneously. This meaning use two of these kind of like motion controllers, holding one in each hand and doing something simultaneously. They said if I had to do it, I could do it one-handed, but if I have to do both hands at the same time, that's not going to work. So that really got us thinking about like, hey, there's going to be a big population of people in which two-handed or, this bimanual interaction is just not going to be a great solution. So we need to think about what else can work there. So we kind of start off with this question of, well, how do we allow people to control kind of bimanual interfaces with unimanual input? So I want to kind of give big credit to Momona Yamagami, who was my intern last summer. She's currently a PhD candidate in electrical engineering at the University of Washington, and she joined our group this summer and helped us think about this question. So we thought it was pretty interesting and thought it, something that we should explore. So there's actually been a lot of prior work looking at kind of what people call like asymmetric bimanual movements. So we were actually able to say like, okay, if we want to understand bimanual actions in VR, what are in general the types of bimanual interactions that exist in just everyday life? So we can actually use this framework from Gyard here to actually give us a way to think about that. So I'm going to go through this really quickly, but I think it's a really powerful way to think about this. So there's really 4 different categories of bimanual interaction. So once again, bimanual being interaction with 2 hands. So there are symmetric in-phase interactions. So those are interactions in which both hands are performing the same action and at the same time. So you could think about if you're jumping rope, both hands are kind of moving in a circular motion in tandem with one another. So there's the next one is symmetric out of phase. So this is once again, both hands are performing the same action, but just at different times. So for example, if you're climbing a ladder, you might move one hand up another rung, and then your next hand would move up the next rung. So both hands are performing this kind of just climbing upward action, but doing it at different times. There's asymmetric coordinated. So this is which both hands are working together on a single kind of object. You can think about it. So for example, if you're cutting an apple, one hand kind of holds the apple while the other hand kind of, does the cutting. And you can think about that too. Like, if you're writing, one hand kind of holds your paper steady while the other hand actually, starts to do the writing. So that's asymmetric coordinated. And the last one is asymmetric uncoordinated, which is probably the hardest one to design for, but it's also probably the most interesting, because in asymmetric uncoordinated, what happens is that both hands perform 2 independent interactions, so independent from one another. So in a video game context, you might think of this as, with one hand, you might be able to thrust with your sword, while in the other hand, you can like bash with your shield. So both hands are doing 2 different kind of actions independent of one another. So okay, so we have this like framework, right? So we're like, okay, great. We can think about these different types of interactions. So the next part then is thinking about, well, how do we want to think about designing the interaction technique? So for us, we thought about it really as a spectrum or in a scale really. And we thought about it as like, okay, well, we could provide less to more autonomy to users depending on, once again, what's their preference. So for example, you can imagine something in which users have very little autonomy. So that could be something in which, let's say, a person encounters an action or a task that requires bimanual input. You could imagine like with no autonomy, you could just have the system just like automatically perform the task for them. So for example, they approach the ladder, instead of requiring the person to climb the ladder, you just say like, oh, okay, they approach the ladder, we climb, you just kind of will ascend the ladder for you kind of deal. So there's something that's kind of like more in between. And that's something that you could think about as like, well, what if we can infer the output of 2 hands given the input from one hand? So given what one hand is doing, can we just say like, hey, I'm just going to put the second hand on autopilot, and it's just going to, kind of go off of what our primary hand is doing. And then the last one is this notion of like, well, we can give people a lot more autonomy, right? So maybe we could just say, give people an alternative input method in general, right? So instead of saying, hey, do something automatically, or maybe, doing something in which something's being inferred from a little bit of input, we can say, hey, maybe to control this like second hand or second controller or whatever the case may be, what if we can use kind of like HMD position or eye gaze or voice or something else as kind of a proxy for what that second hand would be doing. So what you're able to do then is you can graph these things, right? So you can kind of put these things on a spectrum, or you can kind of put these things in a constructed design space from these things and say like, okay, for each of my different types of bimanual interactions, how would I design interaction technique that kind of fits these different types of that fits on various parts of the spectrum we have here about autonomy. So for example, let's think about symmetric out of phase, because I think it's a really useful example. So if we could think about symmetric out of phase interactions to start with, once again, automatic could be something like I mentioned before, you approach a ladder and you just kind of automatically climb the ladder, right? But you could also think about something in terms of, well, how do I want to infer the virtual hand? So there's a couple of different approaches to this. And what we have here is like a kind of simple, naive approach. We can actually think about this getting more complex. So for example, you could do something really simple, right? In which you kind of have the offhand just kind of mimic the direction, speed, and distance of whatever the real hand is doing, right? So once again, this is for these symmetric out of phase type of interaction. So, right, these are these, climbing a ladder or a rope or whatever type of activity this might require. So you can imagine something that says like, okay, I'm just going to have a script in which my virtual hand is just going to kind of mirror or mimic what my real hand is doing. And this could be really useful whenever a person engages in an object that's classified as symmetric out of phase. So that can have some benefits, for example, of like being less fatiguing. You don't have to kind of do double the work, and you can perform these movements simultaneously. But once again, kind of like the drawback, right, is that you have less control. So if you didn't want that virtual hand to do something, but once again, it's kind of being inferred on what it should do, that can be problematic. Another way that you could think about this too is that you could think about this as like a data training example, right? So if you have data of about how people perform interactions with one hand, could you use that to kind of train a model of how the second hand would react in a given type of situation? And then the other one, once again, like I mentioned, is kind of this alternative input approach. So this could be something, for example, in which your real hand or whatever hand the person is manipulating, that's going fine, but whatever the offhand is doing, you just map that to some other type of input method. So you're saying like, okay, if I want to be able to place my hand on another rung, what I'm going to do is actually just map, a ray, I'm just going to shoot a ray from my HMD position and use that as a proxy to determine where I want to place my hand next, right? And we can do that as a way to just kind of understand what might be going on, or might be that might be a useful way to give people more power over what's going on, right? So they can actually have a little bit more control. So like I said, the benefits here are more autonomy and control. People can, once again, perform these movements simultaneously. The problems, once again, come off is like, depending on what you need this kind of like offhand to do, right? So if you wanted something, for example, in which you have kind of two hands holding two objects and the offhand is performing some type of, I don't know, rotation, right? You're rotating a cube to try to get it to, or like rotating a key to try to get it to fit, you probably need something that has similar degrees of freedom as the hand that you want to manipulate, right? And then you could also have difficulty with kind of overloading. The idea being that if you map too many inputs given this one input device, you may, forget or have difficulty understanding what exactly you're doing when you need to perform some type of action. And once again, some of these interactions could be accessible for some, but may not be for others. Once again, that's why we want to be able to provide choice in this way. So this is kind of this is kind of like what I wanted to hit on in terms of some of the work that we're doing currently around interaction accessibility, right? So I just wanted to provide that as like one example of what came out of our interview study and how that's dictating what we're thinking about for future research directions. Once again, we're doing more work with the study, with this project, but once again, it's just really hard to actually be able to validate and, designs when you can actually, have people come into the office and actually try these things and give feedback in that way. So my last thing here is I kind of just want to end talking about some of these future opportunities and, mostly future opportunities from, the document I shared, this accessible by design document, and what we can do next in that space. So I would just kind of wanted to hit on some of these different things. So content accessibility is another big thing here. So just in general, and I think this is also something that's taught in this community a lot, which in general is just like, like, hey, we need kind of more agreed upon methods to make content more accessible. So, we need to do things like understand kind of like what metadata is necessary for different types of content, what standards need to be applied, when you might want to provide alternative representations of something, and how can we allow people to be able to kind of apply accessibility options post hoc, with the idea being that people might be able to bring in accessibility options that work particularly well for them, and maybe some designer didn't think of that a priori. So how can people kind of bring in their own accessibility options into different types of spaces? Another project here, this is something that's ongoing that we're working on, is this notion of inclusive representation. So the idea being that if VR applications allow people to embody all these different avatars, there's going to be all these different types of diverse applications, for education, for work, for, social different types of events, job search, whatever the case may be. And it's unclear, at least from the research point of view, right now, how people with limited mobility would like to be represented in different types of VR environments. So if the idea here being that, you want your VR applications, if it has kind of default avatars or an avatar creation system, that there is inclusive representation, so that if a person chooses to, they can actually craft an avatar that they feel is representative of them in whatever context that may be. And then the kind of last thing here is this notion of application diversity, which is just to say, and this is not new to anybody in this room probably, which is just that, VR allows us to do different things that traditional 2D interfaces don't allow us to. So the opportunity here is to say like, hey, how can we leverage VR to do things that can be done in accessibility context? So things, for example, like virtual orientation and mobility training. There's already been a lot of work about thinking about rehabilitation and physical therapy, which isn't a space that I'm in necessarily, but I think it's an interesting space, right? Just more broadly. And then there's also this kind of way, right, to virtualize existing digital tasks. So, ideas, for example, that have been floated around for a while now, like, can we just replace physical monitors with virtual ones? And what are going to be the accessibility kind of ramifications of that when we get to that point? So kind of just in conclusion, I just kind of wanted to wrap up here by saying, just in general, we've identified, and like I mentioned before, people in this community are probably familiar with these things already, but, people encounter a lot of these accessibility barriers when interacting with VR systems. And I think it's important to really think about ability when designing solutions to these problems. So really putting the focus on what people can do, really focusing on this, how we can leverage existing systems, existing devices, existing platforms to make things more accessible. And then also the kind of this notion of ensuring that VR systems are designed to promote equity for people with disabilities. So we don't want to actually have it be a way in which we create VR systems and the only thing that we're doing is importing the inaccessibility of the physical world into the virtual world, because that's not what we want, right? So yeah, so that's it for me. I'm happy to answer any questions or provide a little bit more context or information around any of the projects that I mentioned. So thank you all for your time. I really appreciate it.
Thank you so much, Martez. And we will now open it up to questions for those of you on the YouTube stream. Also, please type your questions and we'll voice them on your behalf. But for anyone here in the room, if you would like, you can go off of mute and ask your question to Martez directly, or if you would like to type the question into the chat, we'll ask that on your behalf. And you see the emojis for the clapping. Thank you, Martez. Excellent presentation. So anyone have a question you'd like to ask? I'll start off with one since we're getting set there, but I was reacting to your comment about when you did the user study and your participants were giving feedback. I don't care if it wasn't designed this way, like it doesn't have to be the way that it was designed to make it work for me. Like I want to have that experience or this experience. Did you ever have the opportunity to share that feedback with the developer or designer? Or like, I think you were saying that maybe people don't consider that, but have you heard like how people responded to any of the users' feedback about that?
Yeah, no, that's a great question. So, yeah, so we've had conversations internally, kind of within Microsoft, for example, like after we did this research to be able to reach out to people and kind of make this point, right? And I think that there's this, like I mentioned, I'm new to this community, right? I've only been kind of doing VR research for kind of the past couple of years, and what I thought was interesting is that VR kind of content creators for VR kind of reminded me of kind of like filmmakers in a way, in which they kind of had like an idea, right, of how this thing would be consumed, right? So if you're a filmmaker and you're like, okay, I want people to see this on the big screen, right? You feel, maybe upset if people are watching like your movie like on their phone, right, on Netflix or something, because it's like, hey, that's not the way that it was meant to be consumed. And I think a lot of ways that for some VR content creators, I think they kind of had this similar mentality in which they're like, oh, okay, we want to have this experience, and the experience should feel like this, right? Like it should feel like, like you're swinging through the jungle, or that you're doing something, right? And they then create kind of the experience of interactions on top of that facilitate that feeling that they want to be able to invoke. An idea that that we heard from our participants is that, like, I don't necessarily care that this person thought their primary or ideal way for people to interact with this would be to use kind of controllers in this way and to do this and to have the timing be this, and they're like, hey, I just kind of want to be able to enjoy the experience, or to experience the experience, right? I don't necessarily care that it doesn't meet this kind of like content creator's vision. So I do think that's been a useful way of thinking about that. And like I said, just being in the community for a short period of time, I've been able to talk to people who haven't had interactions with people with disabilities using their products and say, like, hey, yeah, like people just kind of want to be able to enjoy it. Like, I understand it's really important for you to come up with something that you think is, useful and beneficial and mind blowing. But at the same time too, right, we just kind of need to be able to provide ways for people to experience these things because that's what they want. So.
Yeah, no, that's awesome. And I think a lot of times people just need to see or be able to experience or meet someone that does need to interact with it differently, and like hopefully it does change those creators' minds to think about it differently.
Yeah.
Okay, we have a question here from Mike Heavers. Are you aware of any standards development work in progress for VR on a level similar to WCAG, Web Content Accessibility Guidelines for Web? Does Microsoft have its own standards or compliance infrastructure in place or making progress around VR for this?
So there are some emerging standards. So there's been a lot of these different types of I'm not exactly sure to call them, like associations and working groups. There's like the XR kind of like association. There's like the XR Access organization in different places. So there's been a lot of work that's been done developing these standards, and I know there's one in particular that I'm blanking on that I can't come up with the name for, that is like more like a web type of like XR standard. And I think so. To your question internally at Microsoft standards compliance. So yeah, so in general there's kind of like compliance in place, for I think Microsoft products, like more broadly, just as kind of like common business practices, kind of compliance type of things. And I think, I'm glad this question was asked, right? Because I think, I think it gets to this point, and I try to talk about this in, or I try to evoke this sometimes in my research, which is that, like, I think, a lot of times when people think about accessibility, they compound it with, or they conflate it with compliance. I think like people think about those things, in certain ways. It's like, hey, like when is something accessible? Like, oh, if it meets some type of compliancy, it meets some type of legal standard or something like that. And I think one of the things that I've really been fascinated about doing in my research has really been trying to think about, like, like, hey, shouldn't accessibility in this context just be like, people, yes, of course you kind of want to be compliant, but like to me, that's kind of like the floor, right? I think a lot of people treat compliant as like the ceiling, like, oh, we got compliancy. Okay, we're good, right? We kind of covered our bases. And I really think it's like, hey, like, yes, compliance should kind of like be the floor, and we should really be striving to create kind of like the most amazing experiences in the best way possible, you know, for people with a range of different abilities, right? And I think that some of the work that we've been trying to find, or at least in the area that I've been identifying, is that it's just really hard right now to understand how we would create how would we create accessible experiences for the range of different types of um, abilities that people have on the input side that I think makes it really tricky. So I think, for example, on the output side, so for example, if you're thinking about like, well, how can you make 3D videos, for example, more accessible? So it's kind of like you have this kind of like content consumption problem, like, hey, I want to consume this content. How do you make it accessible to me? Whereas I look at it primarily on the input side, like, hey, I want to be able to interact. Can you make these interactions accessible to me? And I think we're just unfortunately really far behind on trying to understand on the input side how we can get up to these notions of like standards and compliance and all these different things, right? To make it so that people with a range of different abilities can use these systems. So for once, I think like a simple example for that would be, right, is like, if you imagine someone who might have like, who might be in late stages of a neurodegenerative disorder, like ALS, for example. But let's say this person uses primarily eye gaze as their input method. As far as I know, there's ways that you can create accessible interactions with just eye gaze. Like there's things that you could design, kind of like bespoke interactions, applications that just say like, hey, with eye gaze, look at all these things I can do. I'm not aware of any kind of like general purpose eye gaze solution, right, for like VR systems. I'm not aware of anything that would necessarily be like, hey, yeah, if you have an eye tracker, it doesn't really matter what VR experience you load up, you'll be able to complete it using just eye gaze as the input method. So even something like that, right, of just saying like, hey, for a lot of people, eye gaze is going to be really useful. How can we make it so that VR or whatever the case may be is wholly accessible to somebody who has purely a gaze-based interaction method?
Cool. All right. We're going to take a couple more questions, and Mike just said thanks to you for that. Anyone have another question or want to go off mute and ask a question? Okay, well, I'm good with questions. I'm gonna ask you one more, Martez. So you mentioned you did a study with like 3 different, well, multiple studies, but you had the slide where you had done a comparison or maybe an evaluation of 3 titles. Was there any VR title or sort of experience that stood out as a better implementation or that had more availability, from the ones that got evaluated?
Yeah, no, that's a great question. So, I would say not really. I would say, we try to, we were trying to look, so we chose those applications specifically because we were looking for kind of a broader range of different types of, of, of kind of like interaction styles that might exist in those applications. So for example, when we did the kind of, we had them do the Oculus First Contact application. So for that one, for example, there's not much you do except kind of play around with these different interactions or with these different objects that exist in this kind of lab. But it was really good because it kind of required people to, have to perform these different types of hand gestures. So it's kind of like a scene where it's like, oh, you have to kind of grab a cassette and place the cassette into something. So we're like, hey, this is great because we can demonstrate kind of like we can evaluate how well people can use these controllers to do these hand gestures. And then it was kind of like, all right, when people did Google VR or VR, yeah, like the Google VR Earth experience, it was like oh yeah, hey, people have to kind of use these two controllers in this way to do something. How would this work? You know, All Space VR is kind of more social VR application-y. So it's kind of like, oh, how would you how did people teleport when they were trying to navigate the space? How did people, you know, walk or interact with the different objects? So I would say that particularly there wasn't anything that stood out outside of those kind of like higher level themes, because we were really looking at for that project, really the hardware. We were trying to say like, hey, at what point does like the hardware provide people difficulties? And then I think some of the work that we're going to do, hopefully, once we're allowed to you know be around human beings again, is looking at like more specifically these different types of interaction styles. After we can kind of come up with some hardware that we think can actually be really beneficial.
Great. Well, I want to just then say thank you so much for your presentation today. And we did note in the chat, your slides are downloadable. Looks like we've made them downloadable via being uploaded, but we will also post those to the Meetup site if that's good. And we really appreciate everyone coming today. We will have a little time after this presentation, so if you didn't want to ask a question on the stream, we can have a conversation still in the space at the completion of this meeting. But we thank you for coming today, and we will be hosting our next meetup with Jonathan De Armas from Diamond Group, who's here today in the space. We are planning that for April, our next presentation, and we'll be posting details about that on the Meetup page. But thank you everyone for coming, and thank you again, Martez Mott, for the presentation. We will end the stream and start the socializing.